Awesome. Glad everyone could make it. I know it was a rocky schedule. I'm excited to be talking today about, is your service mesh Istio AI ready? So I'm going to talk to a lot of people. Like, this AI hype cycle has been probably the longest lasting and biggest hype cycle that I've seen in all my years of coming to KubeCon. And so I've been talking to people about how to run AI infrastructure for quite a while. And when we first started hearing about this, I kind of thought, I get the question, do I need a service mesh to run my AI, or can I use my service mesh to help with my AI problems? And I said, of course you can. Like, this is a service mesh architecture. You have your ingress, your egress, and your services service traffic. Istio is designed to be this agnostic layer that gives your application zero trust security, observability, advanced traffic management. Your AI applications are just applications, right? We have this generic service mesh layer for this very reason, so that we don't have to go into all of your applications and implement bespoke logic each time, right? You use this common infrastructure to get uniform policy enforcement, et cetera. And I kind of stuck with that for a while and said, no, we don't need to do this AI stuff. We're future-proofed to AI, right? And I think as the years have progressed and AI has become more mature and the use cases have expanded, that's kind of shifted in the wrong direction, right? I was a little bit right, but at the same time, there's a lot of use cases in AI that make more specific, tight integrations and support for this AI functionality something of value, right? And so it's a little bit right, but there are ways that AI and service mesh can more tightly integrate and bring value. So I'm going to talk about some of the new requirements that AI is putting on our infrastructure, our service mesh, or API gateways, our networking stack. We're going to talk about a few different areas of AI. AI is a somewhat broad category. So we're going to talk about LLM consumption. This would be like calling out to OpenAI or Anthropic or other things. LLM serving, which would be running your own models in, say, your own Kubernetes cluster. And then MCP, which, if you're not familiar, I'll explain what that is as well. We're going to talk about how Istio can handle these today, where it excels, where it struggles, and kind of what the future holds for Istio managing these protocols. So just to go back to kind of the standard Istio architecture diagram, what this looks like is with AI workloads is very similar, but just some subtle differences, right? So when we're talking about egress, we're probably talking about egressing to an LLM provider, right? Like ChatGPT, Anthropic, Gemini, all these different things. When we talk about our applications, we're probably now calling them agents thanks to our marketing team, right? You can't have an application anymore. It must be an agent. The applications we're hosting may be things like VLLM, for example, which is a technology to help you run your own models in a production-grade way. And we may also be running our own MCP servers as well. So while we have the same components, they're now more specialized in doing specific things, right? And this matters for reasons I'll get into. In each case, there's different requirements that these are bringing. So first, we'll start with the LLM consumption side. This is like the calling out to Anthropic or OpenAI. This use case it almost feels very similar because we have an egress gateway, but the models of the way the traffic behaves is fundamentally different in a lot of ways. So with the LLM consumption, you're typically calling these things out of cluster, whereas before, most of your applications probably run it in the cluster, right? You may have a few external calls, like to the AWS APIs or something, but the majority of your workloads, generally, you run yourself. That's not really the case with these AI workloads. So we see a lot of users for the first time facing the requirements of controlling egress traffic to these external applications. And the types of traffic are a lot different as well, right? Like a traditional RESTful stateless service is going to be handling high volume of traffic that's relatively low cost per request, and it's probably latency sensitive, a handful of milliseconds per request. The LLM side is totally different, right? These requests are super high latency, and they're very high cost per call, right? I've made a single request to an AI provider that costs $1 for that one request, right? And takes 10, 30 seconds to complete. And we generally, before, would operate on requests. We're generally not operating on requests on the LLM side, and instead operating on tokens. If you're not familiar, token is very roughly like a single word in the conversation. And it's usually how these LLMs are billing things, right? They operate on the cost per input token and per output token. And we're tracking not just single requests, but whole conversations as we chat back and forth with these LLM models. So these subtle differences, they sound small, but I'll show they add up to big differences in the requirements. This helps a bit. I promised I wasn't going to put too much JSON on presentation, but we need a little bit to get a kind of a glimpse of what this looks like. So this is a very simple example of what an actual LLM call looks like at like the protocol level, right? It's very simple. We call an API. OpenAI is called chat completions, kind of weird name, but whatever. And we say, I want this model, and here's my request, right? Pretty simple. And in response back, we get a message that looks like this. Here was the model I used. Here's the response. You said hello. I said, thanks for asking. And we get this usage metrics as well about these tokens that I was talking about, of how many input and output tokens were used. Now, there's a few tricky things about this. If we were to look at, say, our access logs for these request patterns in Istio logs, you'd see something that looks like this, which is maybe slightly useful, but mostly useless, right? I can see they're calling OpenAI a lot, but I have no visibility into what's going on, right? Were they sending very inappropriate messages? Were they massive requests with millions of tokens that cost $1 each? Or tiny hello ones that costed next to nothing, right? We don't have that context here. And so if we look, we'll find that actually a lot of the areas that Istio is giving visibility and access controls are not applying directly into the LLM consumption world, because so much of the information that we need is stuck in this JSON body, whereas Istio and other traditional service meshes and API gateways are really focused on things like the headers and the path and things like that. So we have new requirements here, right? Like the number one use case I see with people deploying AI is I need to understand what's going on. I need to audit all the messages coming in and out so that once my application tells someone something offensive or dangerous, I can go look and say, how did this happen? Why did this happen, right? Huge requirement. But it shifts because Istio is not logging the request and response bodies, right? And this all applies back to the unit of economics before, right? If I was to log in a traditional high volume, low latency microservice all the request bodies, the cost of log processing is probably well beyond the actual compute to serve that workload, right? It's not the case now. If a single request is $1, the cost to log what that request was is pennies and completely irrelevant compared to that cost and well worth it, right? Another thing is like doing rate limiting or cost attribution, right? Again, we don't want to do this based on a request. We want to do this based on the actual unit of economic, which is tokens, right? I'm getting charged based on I use 12 input tokens and 300 completion tokens, right? That's how the OpenAI is charging me. So I want to be able to limit my users based on that and say things like, this user can only access 100,000 tokens a day or things like that. And when we want to monitor performance, we also may not want to look at just the request level metrics like the whole response duration, but maybe something like time to first token, which would be like how long it took to generate like the first token, which here would be high, or the time per token as well. These are generally the two core metrics for LLM performance. So if we look at the requirements, like the general requirements we see coming up a lot with this LLM consumption use case, one of the big ones that Istio is really great at is API key management. Usually when you talk to these providers, you pass them an API key. And without a centralized egress point that Istio offers, you're left with handing out all these API keys to all your different applications. You may have multiple providers using, so you have this crazy matrix of applications and API keys to manage. What happens when one's compromised? How do you roll these out safely? All these sorts of issues, right? That Istio egress gives you a centralized place to control access to these. That we can additionally add authorization policies to control who can access what, right? So we can say, these applications can talk to OpenAI with this API key, but this other one, it shouldn't really be talking to OpenAI, so they're not allowed, or things like that. On the observability side, we do have in Istio a lot of rich observability support in terms of logs, metrics, tracing. It's not fully to the level, I think, for optimal LLM observability in terms of like seeing the prompts and completions and things like that. So I think there's some room for improvement there. But there's definitely some good core level visibility there, as well as authorization. So like we can authorize based on higher level concepts like can they access OpenAI or can they access the API tool, but not necessarily on more fine-grained things. Like some of the things we're seeing in the LLM space is actually using like another AI, for example, to authenticate or authorize a request, which is often called like a guardrail or a prompt guard, which can do things like ask them, is this prompt attempting like a jailbreak, or is it using inappropriate language or things like that? Because these workloads are so non-deterministic, just a static authorization policy is no longer always sufficient, right? Some other use cases that come up is the rate limiting as well based on tokens. This is not something that's really offered by Istio today. Some more advanced stuff that's pretty rare even in any part of the industry today is something like semantic caching. Like my first request I sent in that example of, hi, how are you doing today? It might have costed me a penny to send that or something, but the value is pretty low, right? I probably have a lot of people saying, hello, how are you doing to the bot? And we could cache that response potentially and send them back. That's not something that's well supported by Istio today. Another one that is coming up is provider or model failover. A lot of these LLMs are either unreliable in terms of just being totally down, or unreliable in terms of having huge latency spikes, or even sometimes the quality degrades when they're at high scale. They'll say they don't do this, but it's controversial. I don't know. And so being able to dynamically select which provider or which model within that provider is something that's really powerful to do this. Istio doesn't really have that fine-grained level of failover at that level of provider, or like at the model level. There is higher level failover, but in order to do provider failover, you need something like a universal API, really. Because Anthropic and OpenAI, for example, they don't use the same APIs. And so if we don't know until, in the proxy which one we're going to send to, then the client would need to send like one API and have that translated into the provider one. So that's what kind of a universal API is doing, and it's kind of a prerequisite for provider level failover. So overall, we have some great ways that Istio can augment and help with consuming LLMs, but it's not necessarily the full, complete vision of what kind of an optimal LLM solution might look like. The other side of this is LLM serving. So we talked about consuming an external LLM, but we may also want to host our own LLM, right? There's a lot of great open source models that can be run on your own infrastructure these days. Some that can run on this laptop mini that require very, 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 very expensive GPUs, like DeepSeek and Qwen. So I have $8 signs here. There's only $4 signs on a restaurant, but GPUs go to 8 and beyond, right? So the thing that's interesting with this serving stack is that because they're so expensive and because it's such a common workload, well, it's becoming increasingly common, it's worth optimizing, putting a lot of engineering effort into optimizing this very specific thing, right? Like I think anything that you specialize in, you can be a bit better, but it's probably a bad return on investment to make the super optimized shopping cart service load balancer if it's only going to make your shopping cart spend 1% faster, which saves you, a couple dollars a month. But because a lot of people are using a lot of GPUs, like millions and millions and billions of dollars, making that serving stack 5–10% better is worth the return on investment, right? And so there's been a lot of efforts in the industry to build specialized LLM serving stacks that are optimized specifically for these workloads. So here's an example from GKE. I just picked them because they had the first graph I found. Of a optimized load balancing for LLMs that they developed, and this is kind of the results. So you can see that the orange is like with just generic like round robin, those sorts of load balancing algorithms, but the blue is a more optimized approach. This is even using a log scale. I'm not sure why, because they would have looked better without the log scale, but the results are pretty good, right? We have like 10,000 versus 1,000 in terms of milliseconds for the first token, for example. Even better news is that all this effort is being done in an open source project called the Gateway API Inference Extension, which is part of Kubernetes Gateway API. And what it's basically doing is taking this Gateway API and adding first-class support for routing to inference workloads or LLM serving workloads. And what this does is basically take any existing gateway that supports it, which we'll get into in a bit, and allow it to call out to this optimized LLM-aware load balancer that's taking in factors like caches on the GPU, what models are actively loaded on the GPU, what's like the queue depth on the GPU. There's a whole sort of things that is well beyond my expertise that's deeply integrating with the application itself. And the application here being the VLM is, I think, the only one they support, which is the inference serving stack that you would run. Even better news is that Istio itself also fully supports this specification, and as of a few months ago, has fully rolled this out into Istio. So even today, you can use this inference extension to run your inference workloads on Kubernetes and have Istio optimized the performance of them. So we have, like I said, LLM-aware load balancing here. We have full conformance with the inference extension API, so they have conformance tests to make sure that you're doing things properly. For example, we're one of a small handful of gateways that are conformant. And so all of this is pretty great. I say just one caveat is today, this is still quite new. I think, yeah, this is the end of July, so just a couple months ago. Right now, this is supported on Ingress. Coming up in the future is support for when you call these workloads from your sidecars or from your waypoints. The other thing I would say is that if you're serving your own LLM models, sometimes you're serving them to external clients, in which case how they consume it is up to them. But oftentimes you're deploying them for your own internal consumption, right? You're deploying your own ones because you want specialized models or privacy or other things. And so the LLM consumption and the LLM serving really go hand in hand, right? Because you're doing both at the same time. So having a single stack like Istio that's handling both of those is really powerful. So you have kind of the single pane of observability, security, et cetera. All right, next up is MCP, or Model Context Protocol. If you haven't heard of this, I promise you'll be sick of hearing about it by probably this time tomorrow. This is the most hyped thing at this conference and in the industry right now. Basically what it is, in their own words, is a way to connect your AI applications to the world. So what this means is, if you look at the early LLMs, you can talk to them and they can tell you information that they know about from what they were trained on, but they can't really do anything, right? MCP is a way to give the LLMs the ability to actually interact with the world and what they call tools, right? So there could be a web search tool or a create GitHub issue tool or send an email. And it makes it's really what powers the new agentic model of AI infrastructure, where you're kind of actively working with your AI as kind of your companion. You can tell it, go send this email based on what we talked about, or go create a GitHub issue, or ask it, fix this bug, and it knows, I'm going to search the web. Okay, I need to search through your code and do all these different things. So it's a huge leap in ability for usage of LLM. Now, the problems with MCP come a lot of the same ones as the LLM consumption side. How do we manage this with the service mesh? Again, I have to show the JSON for it to make sense. So we need to look at what MCP looks like under the hood, right? When we call an MCP server, it's kind of actually fairly similar to the LLM. Like we were saying, we're going to call a tool. We pass it a method, tools call. We're going to say what tool we want. We're calling the say hello tool, and then we're going to pass it some arguments, right? A very generic, abstract, kind of simple to understand thing. And in response, it can tell us a response. So in this case, it said, hello, John. This, I realize, is maybe slightly confusing because I used hello for both the LLM and here. In this case, the tools are generally not like AI powered, right? This is generally like just a normal service that here would probably just be always returning hello name. But it could be doing something like calling GitHub or email or something there. Now, there's a few key things that make this, while this looks like just a super normal standard REST service, there's a few things that make this a bit tricky. First thing is it's stateful. So you can see I snuck in a session header here. What I didn't show, because I limited myself on how much JSON I was going to throw at you guys, is there's a 3-step initialization process that has to happen for each session before we can get into the tool calling, right? And so this is a very stateful protocol. And with state brings complexity around how we manage this with proxies or applications like Istio, right? It's tricky when you have state and you have multiple instances of things that are scaling up and down, both the proxy itself and the actual MCP server. Another thing is the streaming. While there's just a single JSON blob here, there is the ability, and actually, if you are a compliant MCP client, you're required to support the ability to get a stream of objects back, right? So you can see the content type here is not JSON, but actually event stream, or often called server sent events. And so the servers can send back streams of data of JSON blobs, essentially. It's not just one single one. This, again, makes things a bit more complicated, because even if we had, for example, like a JSON response body processing logic in the proxy, it's no longer just one body. Now it's multiple streaming in, and how do we manage that? And last thing, just like the LLM side, everything useful here is in the body, right? If we look at the access logs or traces or whatever, we'll just see they're calling MCP, MCP, MCP. We have no idea, are they calling the say hello tool, or are they calling the delete all the files on our production server tool, right? There's absolutely no visibility there because everything is shoved down into the JSON payload. even worse, is the MCP authorization spec. I don't have time to get into this because the read time's 32 minutes. I'll admit I photoshopped it, but I promise you it takes you 30 minutes to read it. Very extensive, complicated, novel ideas around how authentication and authorization should work in MCP. That puts a lot of new requirements on running these MCP workloads and consuming them. So overall, if we look at kind of the use cases for MCP, things are a bit dicier on the proxy or Istio integration side. This is not an Istio problem. This is seen in every proxy out there. There's a lot of MCP is not a loved protocol by people working on proxies. I'll put it that way. It's loved by the thousands and thousands of people using it, so it's here to stay. But it puts a lot of tricky situations for proxies. So like I said, the MCP-aware observability is pretty rough. Like, we don't really have a good ability to extract information from streaming JSON objects and expose that in a meaningful way. Similarly, we may want to authorize what tools they can access, right? I may give my agent access to GitHub, but I really wanted them to just be able to view GitHub and maybe just view public info on GitHub, not go delete my private repository, for example. But that level of fine-grained control about what's going on in the body needs native MCP support in order to do, which is not something that's in Istio today. MCP authentication, again, I didn't get into authentication, but there's very bespoke requirements that are not something that Istio is natively doing today either. And lastly, there's this concept of multiplexing. Something that we see often is that people are deploying many MCP servers, or at least they want to. And that means that all their clients now need to understand, like, here's my GitHub MCP, my Slack MCP, my Jira MCP, and oh, we added this new one. Did you forget to add that to your agent? Like, now it's not getting this useful tool that it could have access to, right? And so just like with traditional APIs, we expose a centralized access point in like an API gateway. There's an idea that we may want to expose an MCP server as kind of this aggregated, multiplexed, single access point. So overall, on the LM serving side, I think Istio is really good. We're with the state-of-the-art there, and there's a lot of great functionality there. The LM consumption side, we're starting to, we have some useful things there, but there's still some work to be done. The MCP side is kind of more on the cutting edge. MCP, by the way, just came out less than a year ago and had major protocol revisions just like a few months ago. So MCP is quite popular, but quite new as well. So it's not terribly surprising that Istio doesn't have impeccable full support for it at this point. But I think the interesting thing is what's coming to kind of try and fill in these gaps that we talked about. So just like with the inference extension where it's being done in the Kubernetes gateway community, a lot of the AI work is being driven in the Kubernetes community as well. A lot of Istio maintainers are active in those, bringing in the Istio requirements and hoping that we can bring them back into Istio. But we've kind of taken the lessons from the Gateway API to realize that the broader community like Kubernetes brings a lot of value in having kind of this unified API in Istio, but also beyond Istio. So there's a lot of great work being done in the upstream Kubernetes. There's the AI integration working group, the AI gateway working group, and agentic networking group, and a few others. So with 3 committees, we'll work 3 times as fast. But we're working hard to bring a lot of these functionalities into Istio. Everything I think I'd put an X or a exclamation mark. I believe every single one is being discussed in these groups. So they're definitely on the right track. And like I said, this stuff is pretty new, but it has a lot of manpower behind it. So I think we'll see some exciting developments here in the not very distant future. I think next KubeCon there'll probably be a talk of all the great stuff we did in AI in the last 6 months, most likely. Another kind of parallel track, I think this is just great stuff there as well, but I wanted to bring up is that in ambient mesh in Istio, we had kind of designed this layered system that was not just hard-coded to Istio implementations, right? In Istio, there's this concept of a waypoint, which is this independent proxy that Istio can manage and inject into the networking stack. And with Istio, we ship an Istio waypoint that's powered by Envoy, of course, that uses all the Istio functionalities that you would use at the ingress or egress or anywhere. But we had kind of designed this idea that this waypoint was actually this generic abstraction that could be swapped out for a more specialized implementation for specific workloads, right? So we had kind of this idea from the beginning that you may have your general purpose waypoint for your general purpose workloads, But you may also have a specialized AI waypoint when you're talking to your AI workloads, and maybe even a specialized Kafka waypoint when you're talking to Kafka or other protocols like this, right? And so there's this idea that while we are actively looking and working and have done AI native features in Istio itself, there's also the ability for Istio to inject specialized AI gateways and integrate them deeply into the mesh without having to change Istio core itself. So just some examples in the space. Agent Gateway is one example of a proxy that can integrate this way. This is an open source specialized AI gateway that can be plugged in as a waypoint. But this concept is generic and could apply to any gateway, really, if they do the work to integrate with Istio. So if you look at AI gateways on Google, there's like 500 results, probably 400 of them is marketing. But there's a lot of ones that are actually adding a lot of cool functionality, like the things we talked about. So like Light LM is a really popular one, for example, that has a lot of the like guardrails and integrations that I talked about that could, in theory, be plugged in as a waypoint if they were to go do the work to make it a pluggable waypoint thing. So there's kind of two parallel efforts going on. Is like one is, can we take Istio and extend it with these AI native support? And the other path is, well, we can actually plug in these best-in-class specialized tasks for not just AI, but for anything as well. So Istio doesn't need to be the master of every single bespoke protocol, right? We talked about MCP here. There's others that exist out there, like A2A from Google. There's like 50 probably different tiny protocols popping up every day. This is a very actively moving space. And so the ability to just plug in these best-in-class solutions as these protocols are coming and ultimately going, most likely, is also a really powerful path. So with that, I hope you learned a little bit about the problems and solutions of running your AI workloads with and without a service mesh. And I have no idea when I was supposed to end, so I don't know if I have time for questions. Keith, do you know it? Okay, I think I can take a few questions then. There's a mic right there. Yeah, there's a mic here, or we might be able to run you a mic maybe. All right, then we can get the next presenter up. Thank you all.